Hello everyone. First of all, thank you for having me. I am Deepanshu Gupta and I am graduated from Punjab Technical University in Computer Science with a GPA of 8.4. I have 2 years of experience in teaching core concepts of data structures and algorithm. And as my problem solving abilities, I am rated as specialist on code forces and 5-star coder on CodeChef. And I have successfully secured global rank of 74 out of 15K students in CodeChef starter round. And I have also selected for ICPC World Finalist. And additionally, I have solved 1,000 plus problems across various platforms including Lead Code, CodeChef, Code Forces, and Top Coder, At Coder. Yeah. And apart from that, using data structures and algorithm, I have made 15 plus projects using different kind of technologies, Java and Spring Boot with the OOPS concepts. Yes, that's all about me. Okay, so now let's study and let's move to the how my sessions will be conducted in a future classes if you book with sessions with me. Okay, so yeah, let me share my screen and yeah, okay, so yeah. So we have a number of days. I have divided the topic into a days sessions. For example, we have a topic called arrays, and I have divided arrays topic into my 3 days. Part one, part two, part three. In a part one, we will covering 4 to 5 problems of each sections. These 4 to 5 topics these 4 to 5 problems are very easy to solve for the day one. Okay. But in the next day, day two, 4 to 5 problems will be including much harder than day one. Okay. So this way level will be increased day by day. Okay. So yeah, in a day three, we will covering again 4 to 5 problems, but it is much harder than the day two problems. Okay. So in a day four, we are covering most advanced topics which is very really important for the placements, interviews, and core data structures and algorithm problems. Okay, so we will covering 4 to 5 topics of each sections. Okay, so now as you can see, day 4 arrays will be completed. So what about the day 5? In a day 5 we will covering in day 5 we will covering the topic of linked list. As you know, linked list is very very important because linked list stores, each node stores the data and address of the next node. We will study from the basic to the advanced level linked list in my sessions if you book the sessions with me. Okay, so in a day 5 we have covering 4 to 5 topics and part 2, part 3. And now in a day 7, we will covering linked list and arrays. We will see in a day 7 how linked list can be made using the arrays and how arrays can be made using the linked list. And it is very, very interesting concepts. Okay. So for example, let's see a three example, three sum problem. Okay. So yeah, three sum problem. This is a problem statement. Given an array of integer nums, return all triplets such that I is not equal to j and I is not equal to k and I is not equal to k. Okay, so we have to return the sum, three sum equals to 0. Okay, so let's understand the problem statement, how the solution will be conducting. Let me copy my test case and pasted it here. Okay, so yeah. So as you can see, we have to find the three indices such that the sum will equal to the 0. For example, nums of 1. Nums of 1 this part, nums of 2 this part, nums of 3. 0, 1, 2 and 3. 0, 1, 2 and 3. Okay, 0, 1, now 0, 1, 2 and 3. So as you can see, minus 2, 0, 2. This will make up to the sum equal to 0. So we have to find the three indices such that the sum will equal to the 0 part. Okay. So we have to count the number of ways how we can do it. Okay. So minus 2, 0, 2 is the first way. Minus 3, minus 2, 5 is the second way. minus 3, 0 and 3 is the third way. So now how we can solve it? How we can solve this problem using the concept? Okay, so in my sessions we will teaching this stuff. Okay, uh, the time complexity of this algorithm is up to the big of n into log n. I will teach each and every section. Okay, so yeah, let's say day 7 will be completed. Now coming towards the day 8, we will covering the topics called greedy algorithm. What does greedy means? A lalach. Okay, so greedy 4 to 5 problems we are again solving. As you can see in this section, we are given a problem link, a YouTube video, or we can do in an enthusiastic platform. Okay, so yeah, we are covering these topic 4 to 5 and meetings in one room, job scaling problem. You can read the problem statement. uh, Given a one meeting room and n meetings represented by two arrays, start and end, where start of I represents the start time of the ith meeting and end time of the ith meeting. Okay, so we have to count the number of meetings should be scheduled. Yeah, and this one is very, very interesting problem, I must say. Why? Because this problem is solved using the concept called Fermat's Little Theorem. And Fermat's Little Theorem is the concept which is mainly coming in a interviews perspectives. Okay, so I hope you know these concepts and yeah. So the next part is recursion. Recursion. And recursion is also very important. Why? Recursion takes auxiliary time complexity. Recursion takes auxiliary time complexity of this algorithm. As you know, the time complexity is very, very important in a data structures and algorithm platform. In a data structures and algorithm, why? Time complexity. Because we have a problem statement. Let's say we have a problem statement. We have a problem. There are the numerous ways to solve this problem. Okay, so let's say there are the 5 ways to solve this problem. Let's say there are 5 ways to solve this problem. So how we can ensure that the algorithm is efficient? How we can ensure that the algorithm is very, very optimal? How? The algorithm, those which has less time complexity is the better algorithm. Let's say this algorithm is very, very fast and the time complexity of this solution is nearly about 2 milliseconds. 2 milliseconds, and this is 3 milliseconds, and this is 10 milliseconds, and this is 15 milliseconds. This is, let's say, 27 millis per seconds. So which is the best solution to solve this problem? Is this one, right? Because it has the less time complexity. In a recursion, we have to optimize the time complexity of this algorithm to solve the much better questions. Okay, so in this part we will covering the 4 to 5 problems. Let's say combination sum 2, and this is very, very interesting problems. Okay, so I wanted to tell you one thing. What is a problem statement called? Okay, so let's say n is equals to 3. Okay, and we have a k value. We have to k value, let's say 12, and n is equals to 3 means we have a 3 coins. We have 3 coins. 2, 3, 5. We have to repay the 12 number of loan. Okay, so we have to make the values equals to 12. How we can make the value 12? By using these coins. 5 plus 5 plus 2, right? This is the one way. And the number of coins is 3, right? The number of coins is 3 and the sum is 12. Okay, so how we can make 12 again? We can do 3 plus 3 plus 3 4 times. 3 plus 3 plus 3, 12. And this is 4 coins used. Okay, and this is 4 coins used. Okay, or we can make 2 plus 2 plus 2 6 times. 2 plus 2 plus 2 6 times. and make it up to the 12. So which is the less number of coins used such that the sum will equal to the 12. Which is it? Yeah, you know this part, right? This part, right? Okay, so we have to make the sum equal to 12 using the minimum number of coins. Okay, so this is also a very, very interesting problem, I must say, and it is coming in a lot of interviews. Okay, so yeah, in the next step, we will use a recursion and backtracking. Now, I will tell you what is a backtracking mean. Backtracking means the problem we are doing is, let's say, fail at some point. Let's say I'm running at a 10 km per hour speeds. Okay, sometimes I must encounter a wall in front of me. Okay, so I have to return the path from that word onwards. Okay, so this calls the backtracking technique. I will tell you from the back basics how the backtracking will work, okay, in my sessions. And the next up is binary search. Binary search is again an optimal and very important sessions. And why? Because binary search reduce the time complexity from the big of n to log n. Okay, so yeah, and again we are doing from a stacks and queues, heaps, stacks and queues part. We will cover stack and queues and two parts. Okay, day 13 and day 14. Yeah, so let me tell you what is stacks and queues. Stack is based upon the LIFO property, and stack is based upon the LIFO property, LIFO. Okay, last in first out property. Let's say I have put five numbers in my data structures: 1, 2, 3, 4, 5. Okay, so stack says we have to give LIFO property, last in first out. The number which is last put into my stack will come first in my number. Okay, so I have to print in my sequence 1, 2, 3, 4, 5. The number which is pushed last into my data structure is 5. So I have to print the sequence something like this: 5, 4, 3, 2, and 1. Yeah. Okay, so this is called the last in first out property. Okay, last in first out property. And we have another data structure called queue. Let's say queue. 1, 2, 3, 4, 5. Okay, so we have in this session, in this data structure, we have a FIFO property. What is FIFO property? FIFO property is first in first out property. It means the number which is pushed in front of, okay, so the number which is pushed first will be printed as first. 1, 2, 3, 4, and 5. Stacks and queues are the opposite of each other. As you can see, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5. The number which is pushed first will be come out first. Okay. So I hope this much is clear. This is stack. This is stack. This is stack. And this is queue. Okay. So yeah, we will covering each and every part of stacks and queues and how the problems will be implemented. This is tough. Okay. So I must say LFU catch and LFU catch is very, very important. This means least recently used catch. Okay. So next up topic is strings. String is also very important. Um, in the coding, we will write int to give a numbers. Okay. For example, int a is equals to 5. So what about your name? We have to write your name. So how we can define your name? We can define your name by a string. String, let's say Deepanshu. String Deepanshu. String Anvi. Okay. So we can do anything. Like, and yeah. So again, next up part is binary tree. As you can see, we will covering three topics in binary tree. We will covering 3 days in binary tree. Why? Because binary tree is very, very important for the placements perspective. Okay. So binary tree is basically a tree which has at max two children. For example, A, A, B, See, binary tree has nodes and edges, and they have at least two children, and we can make a tree data structures. Okay, so we will covering each part. Okay, and as you can see, we have covered binary search. We have covered binary search, and this is called binary search tree. Now here is the interesting question. Binary search tree and binary tree are the two different topics. We have to cover each one separately, not this difficult type. Okay, so yeah, this is very very important. Again, how we can do a binary search in a binary tree. You got it? Binary search in a binary tree. Okay, so this is very very important. And next up is graph. Graph is also very, very important data structure. Why graph is important? Graph is just similar like of tree, but it is the advanced topic of a binary tree. Okay, so we do in a BFS and DFS, breadth first search and the depth first search. How the this part is going on. Okay, so next up will be a dynamic programming. I must say the most one and only topic in a data structure is important is a dynamic programming. Dynamic programming is really something which you never skipped up. Why? Why dynamic programming is important? Because dynamic programming has a optimal strategy to optimize the solution. Okay, you got it. Dynamic programming has various type of strategies. There are the mainly four type of strategies. First one is memoization solution. Second one is tabulation. Third one is space optimization. Fourth one is diametric graphication. So what is this all stuff? I don't know. So book a session with me. I will tell you each and every part of this stuff. Okay. Don't be nervous. Okay. So yeah, uh, as part of this stuff, we will covering in all topics in 27 days, or we can do a further topics because uh, we have a number of problems we were covering. We are total covering 190 plus problems. If you book the sessions with me, okay, so they all are like in this sheet, 32 are the easy, and 95 will be the medium, and 64 will be the hard topics, hard problems. Okay, so I assume 95 is a huge number, but we have to cover each and every perspective of the problem. Okay, got it, right? So let's say you must complete all the problems and you have all the knowledge of this stuff. Okay. So now what is the next part? How the next classes will be conducting, right? So next part will be conducting as per the this sheet. No, 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 no. Data structure is just like a going to a gym every day. Data structure is like a going to a gym every day. You can't go a gym for 4 to 5 days and lift a 4 to 5 kg dumbbell, right? We have to practice 6 to 7 months regularly to efficient in our data structures and algorithm. Why is that? Because as you know, muscles can be built in a one day, right? Muscles cannot be built in a one day, but brain muscles also be cannot be built in a one day. We have to do a 6 to 7 months of practice, daily coding problems, daily assignments. Then we will do a then we will be efficient. Or see, if you make a Python projects, Java projects, or something like Golang, any language, you have to go through the data structures because it is a foundation of the core programming language, right? For example, you learn a C++, you learn a Java, you learn a Python. You have to go through the data structures next. Then you can build a further projects. Data structure is very, very important. Okay. So yeah, after we completed 27 days of this problem, we will covering these advanced topics. As you can see, there are the number of problems. We will covering each and every part of this. I will share you in an enthusiastic app or enthusiastic platform how the problem will be. This is okay. So I have chosen these topics. Why I chosen these topics? Because it has number of varieties. Okay, number of varieties of concepts. Okay, so I hope this much is clear to you. Okay, So if you want my session, if you want to book my session, the link will be given to you at the Enthusiastic platform. Okay. The link will be given you in a description box. You can check it out. Okay. And don't worry. Um, we will covering each and every perspective of this part. Okay. So link will be given in the description box. You can book right now. Okay. So thank you all. Thank you so much. And yeah.